filters. So thank you and welcome to another episode of the Jane Irrigation Training Series. I'm your host, Richard Rastusha, and today we're going to be talking about filters for irrigation systems. And I'll tell you one thing about why I think this is so important is really every system, in my opinion, should have a filter on it. And so often I see that isn't the case. So really what I'm hoping to accomplish today is one, help everybody understand why everybody needs a filter. And then two, understand which filters are available for your irrigation system. And then finally, how do you select which one is right for your application? So I think those are really important to the success of your irrigation system. And taking us on this journey is Michael Pippen. Now, for those of you who have seen these webinars before, you know, Michael comes from an agricultural background, grew up farming, has worked in for a dealer, has worked in manufacturing. He really has that 360 viewpoint of what's happening in irrigation. He also has a really strong desire to train and educate people on irrigation, and not just irrigation, but the proper irrigation. He's been really involved with the Irrigation Association, making sure that the educational committee in that group works well to offer a lot of good education to growers and landscapers all over the country. So with that, I want to say welcome, Michael. Thanks for taking us through filters today.
No, thanks again, Richard, for the opportunity to share a little bit about what we've learned in the last 20 years or so. And you're right, today we're going to try to focus our topics around filters. You know, what kind of filters are available. We're going to kind of talk about some big buckets of different types of filters, what makes them different, which will help us select, and then why those differences really matter. And that's kind of where we're going to focus our talk on for the next 20 or 30 minutes.
Yeah, so the first thing, though, I got to ask is, you know, I deal a lot with landscapers, and the question always comes up, if I'm pumping municipal water, right, it's drinking water, do I really need a filter on my irrigation system?
Yeah, I would make the argument yes. I mean, we deal with the same thing a lot of times in the agriculture world. Not all of our water is quote unquote dirty, right? We have a lot of good, clean water, relatively speaking. Even here in Florida, we have a lot of shallow wells that are really, really pretty clean, you know, a lot of aquifers and things like that, you know, artesian wells. And so you could, you know, the term clean is a relative term, right? What is clean, what is dirty, but also, you know, how you're really protecting that system. And that's really what, you know, we want to jump this conversation off with is, you know, do I need filtration? And I believe it's best to think about filtration as protecting your assets, right? This filter not only is cleaning the system so that the water so the system will operate correctly, but things happen. And that's kind of how I would say a lot of the landscape water, which is using good, clean water, some of it sometimes drinking water quality, right, before it enters the system. But what happens if your line gets broken when they bury the new fiber optics cable in your yard, like happened in my yard the other two days, and I didn't have a filter on one of my zones, and so for 2 days I cleaned out sand out of my nozzles. Every time they'd pop up, you'd clean one, and then you go to the next one. And so if we had a small filter on there, I would be cleaning one filter versus cleaning a whole bunch of nozzles. And even in some cases, I had to take some of my pop-up heads apart and kind of wash them and put them back together, right? And so that's a pretty simplistic example, but that pop-up head cost some dollars. And so if it had messed up a bunch of them, then that would have been significant and definitely would have been offset by the cost of one filter. And so I think really filtration really needs to be looked at as now how we're operating our system, maintaining our system, making sure it runs properly, but also to protect the asset of the farm, in our case here in the agriculture sector, or your lawn. And I think really we're protecting that, not just our irrigation system, which is a valuable asset, but the most valuable asset, which is either your plants, right? Your plants or the crop, right? That's really what we're protecting. And so, you know, one example that I've given and talked through with during the design process is saying, look, you can have a marginally okay design system, but really good filtration. And that system is going to work marginally okay, right? But you can have a very well-designed system, super efficient, super uniform, but not with a proper filtration, and that system will not operate well at all, right? So it really is a key component in not just the operation, but also in, the protecting of the asset.
Yeah, so that's I bet that everybody who had a break that had to clean out all the heads has a filter every time after, right? So probably if you don't experience that, you might not know the value of that. One of our viewers is commenting, we call filters the emitter guarantee policy, and I like that too. So, and I just want to remind everybody, we've got the chat and the Q&A open. So if you've got some comments or if you've got some questions, put them in there and I'll get them to Michael as we're going along. And just so you know, too, we've been given some great Jane shirts and hats for good questions. So we've been mailing those out for the good ones. So put them in there. Let us help you out.
Perfect. Thanks, Richard, for reminding there. Let's see if I can make this presentation move where I want it to go. So we're going to talk kind of these big buckets, which is kind of how I like to do this organization. There's a lot of filters and a lot of nuances to the different types of filters and how they operate. But we're going to kind of talk in these large buckets or silos about the three types of filters we most commonly see in irrigation. The first would be a sand media filter. And that's this big bank of filters here that you see lined up in a row. Primarily used in agriculture, but could be used anywhere, right? But this is pretty typical in our larger agriculture applications, sand media filter. Here in the bottom left is a relatively large ag screen filter. I should have put you a landscape filter, a screen filter here. Landscapes uses a lot of screen filters, a lot of times the plastic ones, because they're a little bit smaller, a little bit more compact, can fit in valve boxes and things better than this big dude can. But same process, screen filter, super popular and super common, it really across the whole United States, but here in the Southeast on agriculture applications and a lot of landscape applications. And then also disc filters. Disc filters are kind of a hybrid of the two, and we'll look at those and how they're used and what makes all those different. I would say, you're going to find a few different types of things out there that don't look exactly like this. A disc filter that might look a little different, a screen filter will look a little bit different, even a sand filter where the tanks may not be in a straight row. They might be in a H pattern or something like that, but that doesn't really affect what makes them different. And what makes them different is the actual physical thing, if you will, for lack of a more technical term. What is the thing that is separating the material from the water, the bad from the good? What is the thing that is doing that? In a screen filter here in the top left, you'll see how the screen filter operates. The water comes in one side, in this case comes in from the left. The water goes into the center of the cylinder. Here's a little graphic here of the cylinder, a screen filter cylinder, a screen filter element. The water goes in the inside and filters from the inside out. That's how a screen filter works. It's a screen just like you'd have a screen on your door or screen on your front porch that keeps the mosquitoes out, right? It is a web typically of metal, but it can be plastic or in some cases a nylon or something like that. But it's a screen that keeps the good stuff separates the bad from the good. Media filters, sand media filters, use sand to separate those good from the bad. And here's kind of a cross section that I kind of pieced together here where a set of those tanks, but the water kind of comes in the top and goes through this bed of sand and then comes back together and goes out to the field. And the sand is actually what does the filtering. These big agriculture filters are very similar to what you'd see like a swimming pool filter. You've ever been around one of those, the big tanks that are around by the swimming pools. Same concept, a little bit different construction, but same concept. The water goes through the bed of sand, and the sand is what actually catches the particles. And here on the right is kind of this hybrid form that I said that we described, a disc filter. And it has these little layers of disc that stack on top of each other here. And you can see a disc filter element stacked up here on kind of on the top right, and then what one of those individual discs look like. So these are not one solid piece. It's a whole bunch of them laying on top of each other, and they filter from the outside in. Screen filters inside out, disc filters outside in, sand top to bottom. Really, the difference there is what is the key difference in these is what is actually doing the filtering, right? This, in one case, is a screen, one case is a disc, and one case it's sand.
Okay, we've got a few questions we need to answer now. So first question's about the sand filter. Intuitively, if I'm thinking about getting clean water, I really don't think pushing it through sand coming out the other side, it's going to be full of sand, right? It sounds like what I'm trying to stop. So what keeps that sand inside the tank? How come it doesn't end up in my line?
It's a great question, right? And there's a lot of ways that gets tackled. So we'll stay pretty generic with our answer. But the best way to describe it is that there is a screen of some sort on the bottom. Now, that's done, like I said, in a variety of different ways, but it prevents the sand from moving through. One thing that I think is worth mentioning is this is a very specific sand. We didn't just go in my backyard here and dig up some sand and put it in there. That would be a bad idea. That would not work. This is a very specific type of sand. Most commonly use a carbon silica sand. It's been graded, it's been sorted. It is all very similar in size, which is important. You wouldn't want one big piece of sand and a whole bunch of little ones. That wouldn't work. And if you take this sand and put it in a microscope and look at it, it has all these little points all over it, right? It's not smooth like a wash gravel in the bottom of a creek you're wading across, or even at the beach, right? It's very different than that. And at a very small level, when you look at that, it's got these little pointed edges all over it that help grab stuff, right? And so that's how the sand works. It does work. It'll actually grab sand and sediment. This sand can be used to filter out sand and sediment, and often is in a lot of our applications in the central U.S. on subsurface, and then also out in California as well. So that's how it works. It's a very specific sand. That's one. And two, there's also some sort of barrier or screen mechanism at the bottom that keeps our very specific size sand in the tank and keeping it from going out to the field.
Yeah, no, that's interesting. I never thought about that, sand to filter sand. But again, like you say, very specific. So the screen filter you're showing there, I think it's showing like the water spinning. Is that a spin clean filter?
That is correct. That is our Jane spin clean filter. It has a cyclonic action in this type of a filter. Not all screen filters do this, but the idea is that the water comes through this element, and there's actually a plate in there that helps create that cyclonic action. The heavier stuff tends to separate out and also kind of accumulate on that screen filter. And when you open up this flush valve in the bottom, all those velocities get higher, right? So it kind of will cyclone the water in there, cause some disruption, get that sediment back in suspension so it can be flushed out the bottom. There's still not ever a real substitute in a screen filter than just pulling it out and getting your brush that is the right coarseness and the right material to clean out that element. There really is hardly no substitute for that, but this is a really good way to get a system, keep it, if it hasn't got clogged all the way, this will keep it from getting clogged up too much and keep you in operation until you can have time to pull it out and clean it, get it back to completely clean.
So it'll save me some labor. I won't have to clean it as often.
That's correct. That's correct. And in some applications, that's all you ever have to do, depending on what you're collecting. Sometimes you can open this up at the end of the day and flush it for 5 minutes, and you never have to take out the cartridge. Most of the time, people don't get away with that, but it is possible in a really clean water application where the spinning feature is good enough to not have to take out the element.
Okay, great, thank you. Those those are some great questions.
Yeah, thank you for those questions. And so, why does it matter? So why a screen? Why a sand? Why a disc? And when you start talking about filtration, if you really look at it from just the point of view of what is the quote unquote best filter, or what is the key specification from filtering, just removing water, you kind of have these two components. You kind of have this capacity and surface area, right? So the more surface area you have, the larger screen you have, the more material you can catch. A screen filter really works on these two dimensions, right? You kind of got a left, right, and an up, down. It is just like a screen on your front porch, like we said before. So there's really not a depth to it. It's kind of one line defense. This works really well with inorganic materials like sand. It can catch up right there. And then, like we said, we can turn on that cyclonic action. That sand will release and flush out. Works really well in those applications. We sell a lot of them and put up a lot in operation in the Southeast, where we're using like a micro jet or a micro sprinkler where the filtration requirement might be isn't quite so much. We're coming off of wells, don't have a whole lot of organic materials in there. We have a lot of high volumes and relatively low amounts of sediment in the water. They work extremely well in that kind of application. If you look, kind of take a step towards this sand media, we're going to filter from the top down, right? Not from the middle of the center out. We're going to filter from the top down. So we have this third dimension, if you will, right? It's a screen filter. If you take this circular cross section and start looking in on the top, you'd have a screen filter on top of a screen filter on top of a screen filter on top of a screen filter. You have an extra capacity because you have this depth. So one, surface area. Two, in a capacity standpoint, the sand, that depth, can oftentimes be more effective with inorganic material like algae or iron bacteria. Because if you take, something gooey, organic, soft, slimy, and you take it to your screen door, you can put a little bit on there, but if you start pushing too much on it, start getting it clogged up in a filter standpoint and push it through, that stuff can kind of squeeze through it, right? And while it squeezes through there, that might be small enough to not clog up your stuff. It goes downstream and then it's sticky and gooey. It finds a buddy and it gets together and then it causes a problem. So that sand filter gives us an added depth to where it's harder for that organic material to push through. It adds some, not just surface area, but also some capacity. You can just catch more stuff before it's clogged, is what a sand filter can do. The disc filter is somewhere in between. It has a depth as well. These rings are not two-dimensional surface like a screen would be. They have a little bit of a depth. They do not have 18 inches of depth like sand does. They have an inch and a half or whatever it is, 1 inch. But that's the idea when they filter from the outside in. Those, if you can see there, it's kind of hard to see, but there's little grooves on there. There's all kinds of different patterns and designs of those grooves. But they essentially go from big to little, right? They channel down. And so big stuff kind of gets caught out there and then it gets wedged, but it doesn't get like crammed all the way in there like screen filter can tend to do. Gives you an idea, at least a fighting chance to kind of flush that material back out. And it could catch more than one thing in that channel because there is a little bit of a depth to it. So that's why those differences matter, is because each one of these things that we referred to earlier that actually doing the filtering, taking the bad out of the good, they have a really unique application to where they function the best. And a lot of times there might be two filters that work in a certain application. There's not always a clear-cut best, but the material or the thing that is actually doing the filtration really drives a lot of our decisions on which product to select. They all work in individual applications a little bit differently.
So a disc filter might be better at catching a certain kind of debris than a screen filter is.
Yes, correct, and vice versa. So if you take a disc filter typically would be used with something that had maybe a little bit more material, a little bit more organic material because it has that depth. But if you had a lot of sand and you didn't really have any organic material, that sand can kind of get wedged in those discs and they open up to flush. And if all that sand doesn't get out, they tend to sometimes not want to stick back together, and now you got a gap and stuff can just fly through. And so, it's kind of one of those things, is what is the best? And that doesn't mean that they can't work in that application. There are a lot of disc filters that work in, wells that have inorganic material. There's a lot of screen filters that are out there working on open water sources with organic material. It's just, these are some of the nuances of why that is important to really think about what is actually doing the filtering.
And it's interesting too, because if you have issues with water, for example, when I go to the western slope of Colorado, where they're pulling a lot of dirty runoff, I'll want to talk about, smart controllers, and they'll say, but what about filters? Let's talk about filters. You can tell when there is an issue. And then I start to think, well, isn't, algae bloom and things like that an issue? And it is, but it's a bigger issue of all the sand. And that's why they tend to like the sand media filters or the screen filters over the disc filters.
That's right. They all have their pros and cons. And also some of what you're used to managing. They're like everything, filtration, surface area, and capacity are very critical from a designer standpoint, trying to figure out which one of these is going to work best in this application. But we also don't all drive the finest cars or have the best, newest iPhones and all those kind of things, right? There's always this cost consideration floating around in there. And some of these cost more than others, right? Some of them take up more space than the others. You might have, you got a field. When you saw how big that sand media tank is, right? That's a big piece of equipment. It takes a big piece of equipment to set it in place. It takes a good bit of labor sometimes to manage those things if you get them clogged up. There's a lot of things going on there, where a screen filter is pretty down and dirty in terms of, efficient. Not a lot, basically no moving parts in it. And so there's always more considerations than just what capacity. Bigger is not always better, right? There's in the design process, some backflush better than others. I kind of refer to that with those disc filters. Sometimes a disc filter, if it's not managed properly, they can tend to not want to just settle back down in place. Same way if you take a screen filter and you clog it up really bad and you put a lot of pressure across it, you can either push material out to the field or you can collapse your screen. I mean, they all have these drawbacks. But when you're looking at those considerations, I really like to stick around the surface area and capacity. Kind of start thinking through which filters could work, and then what the drawbacks would be. You talk to your producer and say, get a feel for what kind of experiences they have, and then start looking at some cost considerations. We have a really, really large farm, a really high value crop. They've got a lot of acres, probably taking up a pretty big section at the corner with a slab, and having 4 or 5 or 6 tanks is probably not that big of a deal. If you've got a cotton grower, that might be a big deal, right? Have a piece of equipment like that in the edge of the field. Or if you have, a strawberry producer where, is right in town, don't want any of this big monstrosity. You want something kind of compact and clean. All those things are taken in consideration. And we do pull a lot from our experience as a designer. If I put my designer hat on, especially going into a new application, a new water source that really haven't used there. Every one of them is different. Every designer will tell you that. You can have a well, move over 20 foot, put another well in. It might be exactly the same, or it might be exactly opposite. Or you put the suction line in the creek, and it's beautiful the day you're there, and then it rains upstream 2 days later, and it turns into chocolate milk for a week. I mean, those are real live things that I experienced, sometimes the hard way. And so when you're trying to specify these, you also try to get a feel for what that producer is used to managing, what kind of personnel that he has, and what does that look like? Because some of these can be automated easier than others, or function better in kind of a hands-off operation than others. And I think that's also kind of a consideration to look at when you're trying to figure out which filter is right for this perfect application.
And is how often I have to clean it a big issue as well?
It's a really big issue. it's not a fun job, right? But it's a necessary job. A filter can't work. I mean, it's just like your air conditioner or your radiator. I think that's a great, really practical application that I think we've all have had our challenges with at some point in time. You come inside and you're like, man, this air conditioner isn't doing what it's supposed to do. Like, piece of junk, right? And you go out there and the coil outside your exterior unit is full of junk, right? Wasp nest and the ivy that's growing on the side of your house. And so you go clean all that off, and then you go back inside and you go, man, when's the last time I changed the air filter in this thing? You pull it out and it's, caked up with air, with dust and everything from construction. You put a new one in there, and then you're like, oh, the air's working now. That's amazing. And that's exactly how it's filtering, right? It's the same type of thought process. These filters are only going to operate and protect your asset if they're maintained properly. And you could probably make the argument that they're one of the more complex pieces of equipment out in a field. The drippers, they kind of do their thing. Valves can be a little complicated, but they're pretty mechanical in their operation. Most producers and contractors are pretty mechanical minded. They can kind of grab the concepts of that. Filtering is not that easy. It's a moving target. What happened today may not happen tomorrow. And I say that in the sense, you go, how often do you flush? I don't really know the answer to that. I can kind of pull into my historical knowledge and say, if I've got a sand media filter and it's designed kind of around these parameters, and I've got a field in your area, maybe about every 4 to 6 hours, you can back flush it. But really what we're going to have to do is we're going to have to monitor the condition of that filter, just like you would your air filter in your house. It depends on how much you run. It depends on if you decide to cut some sheetrock in your bedroom last night, right? That's not good for your filter. So all these conditions change, and that's why it's super important to kind of keep your eye on these filters on a day-to-day or even hour-to-hour basis, which can be kind of time-consuming, and you have to be trained well enough to understand what that information is telling you. And here we'll talk very briefly about one of the products that we developed just for this application of our Jane Logic Pulse. And it's a very proactive approach to getting this information, rather than having to go to your field and say, okay, I was at 30 PSI going to my field. Now I'm at 20. That's probably bad. My flow rate has gone from 300 to 280. What's going on? You go over to your filter and you go, oh, well, instead of having 3 or 4 PSI difference in here, now I've got like 8 or 10. That's bad. I'm losing pressure out in the field. The nozzles on my micro sprinklers are jet. The flow rate has gone down. It's time to back flush. That can be difficult to train some of your employees, depending on what their skill set is. They might be one of your operators that runs a great spray rig, but doesn't really have any understanding of the irrigation. You can't just send them over there and say, clean the filter. He wouldn't know how to do it, right? He wouldn't know what he was looking at. And so we have some kind of mechanical controls that a lot of people use that are not real interactive. They kind of have these parameters and say, if it gets to this degree, I'm going to go ahead and flush it, from a time or a pressure. But really what we want is kind of this interactive. I don't want to wait to the very, very end and then flush it when I'm about to, where for 3 hours it hasn't been performing correctly. I want it to stay in good form. And so Jane Logic Pulse basically sends that information to you. You get this flow rate information, you get these pressure loss information, and it's pushed to your smartphone so that you see that intuitively. You don't have to think about, okay, oh yeah, it's been 4 hours, so I better log in and check this data. No, it's gonna have these alerts in place that's gonna send you and say, it's time to pay attention to this. Or better yet, it said, hey, it's time to pay attention to it, and I've already taken care of it for you. You can check the report tomorrow to make sure I did what you wanted it to do, right? So it has kind of this full encompassing to where you can kind of take a little bit of that management out of the equation, be a little less mechanical in the way that we flush, try to get a little bit away from a set time and just look at it, because that time can change. So let's get away from a set time or set pressure differential. Let's try to get some real live data that helps us drive those decisions a little bit more in real time.
Yeah, and the thing I really like about what you said was, in your first example, you said you have to drive to or walk to and look at the 2 gauges at the filter. But I think with Jane Logic Pulse, you can see it on your phone, your computer. Is that right?
That's exactly right. I mean, there still is, like we'll always say, I think all the technology guys will agree that there's no substitute for being on your farm. We're not suggesting you shouldn't look at your filter or your pump station. What we are suggesting is that you use the technology to set parameters, build out a program, let it give you good information so should I drive out to the field or should I not? Right? If you need to drive out there and look, let's go look, right? There's no substitute for going out there and putting your hands on your crop or the lawn, whatever the contractor. But if I don't have to, let's not do that. Let's not drive around, because most of these operators have a large enough operation that, you can spend all day driving around the farm, and that's not what we want to ask people to do. What happens in that scenario is the filters don't get managed the way that they should, right? It's not that we turn off the system and say, hey, we're not going to irrigate because we don't have time to manage it. What's going to happen is the management is going to take a back seat and then potentially cause an issue for us down the road.
Yeah. Okay. All right, good. Thank you.
Yeah, so with that, that's kind of where I end my presentation. If we have some additional questions and have a few minutes, I'd be happy to stick around. If not, that my contact information is there below. Also want to bring attention Art Howell, who's our filter product manager, has a tremendous amount of technical understanding of the parts and pieces. If someone snaps a picture of a random filter part and sends it to me, or has a filter that's 10 years old and I have no idea what the part number for that is, I send that to Art, and he has a lot of that knowledge of old filters and how the parts and pieces work together. And so his contact information there is well. And then Kevin Stewart's our ag sales manager for North America, and for the United States and Canada, and he actually put a lot of this presentation together. And so I appreciate Kevin supporting me and some of the graphics and things he did a lot of work on. So I appreciate him, and his contact information there is there as well in case you need anything from him.
Yeah, so thank you, Michael. It was a great presentation. I've got a few more questions here. One, you said somebody shoots you a picture of a filter, a part, whatever. This is okay for people to do.
Yeah, it's easier than trying to describe it. That's for sure, right? I mean, sometimes we wonder if smart things are the worst thing invented or the greatest thing. But I can tell you, for a product manager trying to troubleshoot a product, they are great. Right? Send me a picture of what's going on. Send me a video of the water flying out and tell me what, I think that's great and appropriate. And anybody's more than welcome. I'll actually drop my cell phone number in the chat here at Box, so everybody can have that as well.
No, that's great. So thank you for that. And that's a really generous offer. I hope that everybody takes advantage of that, because Michael's got a lot to offer in the way of help. Also want to say, Mr. Herrera, thank you for your comments and questions today. You'll definitely be getting some cool Jane gear from us. We really appreciate that. And Michael, again, thank you. This was really a great session. Appreciate it. I want to say thank you to all the viewers, and remind everybody that at janesusa.com/training, you can see all our trainings there, or you can listen to them wherever you listen to your favorite podcasts. It's one of my favorite things to think that people are out there working right now, listening to some of our podcasts, bettering their ability to manage water and conserve and be sustainable. Helps me, it gets me going every day when I think of that. So again, Michael, thanks very much. Really appreciate it. And thanks everybody for joining us today. Bye now.